All right, this is section 5.2, and it's zero and negative exponents. And this can be a kind of a hard section, and honestly, when I see kids get into calculus, this is the kind of stuff that they forget and have really messed up on, and it really hurts them. So I'm going to take some time with this and make sure we do a lot of these on video in case you're stuck at home. Now, when I multiply things together, I can change this. I can say this is the same thing as 3 times. When I have a number raised to a negative exponent, it means he is unhappy with where he is in terms of being a fraction, okay? I could put this guy over 1 and make him a fraction. What this negative exponent is saying is draw a fraction bar, move this term to the other side of the fraction bar. Right now it's on top. We've got an invisible fraction. It's on top. And once you move it, it's happy, and it makes the exponent positive. So this ends up being the same thing as 3 times, and I'm filling with a 1 on top if I have nothing left. This is 3 times 1 over 5, which ends up being 3/5. Okay, let's try to do a lot of these. What if I have negative 3 to the negative 1 power to the negative 2 power? All right. There's a couple ways you could do this, but I think this gets to be a little confusing, so I'm gonna just choose to do it just a little piece at a time. We're gonna work inside the parentheses first. Inside the parentheses, I have negative 3 to the negative 1 power. Well, negative 3 is the way it's sitting right now. It's really on top of a fraction bar if I were to draw it in as a fraction. Remember, we can write every whole number as a fraction just by sticking it over 1. But this negative 3, he is not happy being on top. That's why his exponent is negative. So he wants to move down here, and when we move him, he gets happy, and we make the exponent positive. We move it to the other side of the fraction bar, and the exponent becomes a positive. Now, I always fill in with a 1 if I have nothing else left on top, and I don't, okay? So now I've got this as to the negative 2 power. But let me keep cleaning up. This is just 1 over negative 3. I don't really need that 1 in there. So this is basically negative 1/3 to the negative 2 power. All right, well, anytime I see a fraction raised to a negative power, what I can do is take the fraction inside and flip it, so this becomes negative 3 over 1, and then make the exponent positive. That's a quick way to do it. I can make this a very complicated looking complex fraction, but when you have a fraction raised to a negative power, you can flip the fraction and make it positive. That's another way to go about doing that. Well, this just becomes negative 3 squared, which is just a positive 9. Who would have thought that, right? But that's the way it ends up. Now let's look at number 5. You got 2 to the negative 2 times 3 to the negative 1 times 5 to the 0 to the negative 1 power. Okay, I'm going to work on the inside first. So what this is, 2 to the negative 2 means draw a fraction bar, move 2 to the other side of the fraction bar and make it a positive 2, and we fill in with a 1. That's what that first term looks like. Now the second term, I'll underline it in red, and I'll work in red. 3 raised to the negative 1 power just means I'm still multiplying, okay? It means put that 3 on the bottom of the fraction and make it positive. Anytime I move it to the other side of the fraction bar, the exponent becomes positive, and I fill in with a 1. Now 5 to the 0 is kind of a trick thing, because anything raised to the 0 power is just 1. So it's just 1, okay? Now let's work inside the parentheses now. I've got 1 over 2 squared. That's 1/4 times the 1/3 times 1 to the negative 1 power. Well, 1/4 times 1/3 is just 1/12. Remember, when you multiply fractions, you just multiply straight across the top and straight across the bottom. But it's raised to the negative 1 power. Okay, so I've got the inside cleared up. Now that raised to the negative 1 power, what I can do is just say, since it's a negative, we flip the fraction, we take the reciprocal of the fraction and make the exponent positive. And that's just 12 over 1, which is 12 to the first power, which is just 12. Okay, for number 7, we have 2 times 2/5 to the negative 2 power. All right. There's not a whole lot to do here to simplify. I can just write that first 2 down, but since I've got this fraction raised to a negative power, what I can do is flip the fraction and make the negative exponent positive now. That's a quick way to take care of it. So now what I have 2 times 5/2 squared. Now the square goes with the numerator and it goes with the denominator. So 5 squared is 25, and then the 2 on the bottom squared is 4. So I have 2 times 25 over 4. Remember, you can look at this 2 as 2 over 1. We could multiply this out, or we could reduce first. Let's reduce first to save ourselves some work. 2 goes into 2 one time. 2 goes into 4 two times. So now if I multiply, 1 times 25 is just 25 in the numerator, and in the denominator, 1 times 2 is just 2. So it's 25 over 2, and we're just going to leave it that way. We're not going to worry about making it a decimal. We rarely use decimals in algebra. Remember that. And number 9, we have, we're supposed to write without using a fraction. So they want us to basically write it in scientific notation. Now, this is the same thing as 7 over 10 to the 4th power, right? Isn't 10,000 10 to the 4th power? So what we can do is say that this is 7 times 10 to the negative 4 power, because I can look at this as 7 times 1 over 10 to the 4th, and 1 over 10 to the 4th can be written as 10 to the negative 4th. And if I just change that into scientific notation, we just change the dot into this multiply sign that looks like that. And this is all we do here. So we kind of split this fraction up into 7 times 1 over 10 to the 4th, the top and the bottom separately, and then you can kind of follow the logic from there on out. At number 11, 6x squared. So it's 6x squared over y cubed, okay? So if we kind of look at this the way we looked at number 9, all we're really needing to do is move this y cubed up to the top, okay, because we don't want a fraction. So I've got 6x squared on the top still, but if I want to write the y cubed on the top, I can just move it to the top and indicate that it really goes on the bottom by putting a minus 3 instead of the positive 3 that we had on it originally. That's all I have to do. Either one of these expressions would be equal. Okay, so for number 13, they want us to express this as a decimal number. Well, I mean, I could write this as 596 over 10 cubed, yes, okay? But isn't this just scientific notation? I could do that. That's not really helpful, is it? I recognize this because I'm multiplying by 10 to some power as scientific notation. And what that tells me to do is that if you think about it, where's my decimal point in 596? It's right here. And I'm supposed to move it 3 to the left, 1, 2, 3, so it ends up being 0.596. Oh, I'm sorry, I misread that. I'm just looking back at the book, and my eyes are getting old. That was supposed to be actually up here. This was a -2, wasn't it? So I write my 596 down. The decimal point is here. I'm just supposed to move it 2 to the left, so it ends up being 5.96. I just, those little tiny numbers are getting hard for my old eyes to read. And then I'll try to get 15 on here. 15 says 7.2 times 10 to the minus 3. Hopefully I've read that right. So I write down 7.2, and this exponent tells me to move it 3 to the left because it's negative. 1, 2, 3. So I fill in with 2 zeros, and we get 0.0072. Okay.